Good morning. Today we want to determine the FacilitatetAI project guidelines for facilitating the learning of artificial intelligence by school students of grade 7 to 12. This is an Erasmus project. AI 567. Talking about facilitating, artificial intelligence was defined in 1956 by McCarthy as the science of engineering and engineering of making intelligent machines. So artificial intelligence is used for decision making, solve complex problems, increase accuracy, and perform high level of computation. In this project, we decided to talk about FacilitatetAI and how to implement it in school. We decided to make a MonteCarlo simulation for the beginning because MonteCarlo tree search is a search engine technique in the field of artificial intelligence. It is a probabilistic and heuristic-driven search algorithm that combines the classic tree search implementation alongside machine learning principles of reinforcement learning. Thus, MonteCarlo simulations are used to model probability of different outcomes in a process that cannot easily be predicted due to the intervention of random variables. It is a technique used to understand the impact of risk and uncertainty in prediction and forecasting models. MonteCarlo simulations are a series of experiments that help us understand the probability of different outcomes when the intervention of random variables is present. It's a technique you can use to understand the impact of risk and uncertainty in prediction and forecasting models. Thus, MonteCarlo simulation allows risk analysis by building possible models of outcomes, substituting a set of values, a probability distribution for any inherent certainty factor. Calculate the results in several stages, each time using different set of random values, complying probability functions. Depending on the number of uncertainties and their associated ranges, a MonteCarlo simulation could involve thousands of recalculations before giving a final answer plausible. Thus, MonteCarlo simulation produces distribution of probable solutions. We have to emphasize that all the solutions are probable. Thus, MonteCarlo distribution uses probability distribution. There are realistic ways of describing uncertainty variables in risk analysis. Probability distribution used models are normal distribution, like a Gauss belt, used in inflation rates and energy prices. Log normal distribution values are skewed positively in this case, using estate property values, stock prices. Uniform distribution All values have an equal chance of occurring, and the user defines the minimum and maximum. This kind of distribution is using manufacturing cost or future sales revenue for a new product. Triangular distribution, the user defines the most likely minimum and maximum values. Values close to the minimum are more likely to occur. For example, this distribution is used in unit sale, on time, and inventory levels. First distribution is similar to triangular distribution, except that the extremes are not sharp. The duration of the task in a project management model can be predicted by this paired probability. And discrete distribution, the user defines specific values that may occur and likelihood for each consumer behavior. 10 likely% to buy a tablet, for example, 70% to change to buy a laptop, and 20% change of buying a desktop computer. MonteCarlo simulation, it provides a more comprehensive view of what can happen and how likely it is to happen. It involves using a probabilistic model that combines simulated systems. This model involves a generation of random variables which will be functionally related to a solution. After several experience on models, we can choose the optimal solution. Dedicated to analysis and simulation of complex phenomena with a very large number of variables, parameters, with complex relations between components, with disturbing factors. So this is a very useful method. The real phenomenon is replaced with a representative sample. Which are the advantages of Monte Carlo simulation? The solution offered by method shows not only what could happen, but how likely it is each outcome. Results can be presented as graph or different solutions with their chances of occurrence. It enables discovery of variables that have the greatest impact on the outcome. Using Monte Carlo simulation, scientists can see exactly what values are away input variables and when certain events occur. It depends on further analysis. It is possible to model the interdependencies between input variables. It is important for the prediction of the results provided by the model to verify some factors have a positive influence according to the positive negative influence of other factors. The recording believes that I'm not here, so I have to tell them that I'm here. Example of using Monte Carlo method. For example, for the average yield estimation and the riskiness of new product. The user can choose the product that will enter the market. Net count forecast, predicting structural cost, acquisition cost, net income, determining susceptibility to various risk factors such as interest rate changes and exchange rate fluctuations. Determining the optimal amount of production materials that would be reflected in the final product. Pricing of costs of complex financial derivatives and determining the risk of investment portfolios. Determining how many units of each product line provides could be ordered per time unit. Choosing the best option for two or more choices to renew a contract or postpone a project. Determining optimal investment strategies for retirement. Let's see which are the working steps for Monte Carlo simulation. First step is to determine the most significant variable or component of the model and determine a measure of effective of the model variable that were studied. Second, series of observations are conducted. For each variable studied separately, it will be recorded or one range of occurrence variable values and their corresponding frequencies. It outlines the cumulative probability distribution of the model, graphical plot possible cumulative frequency curves for each random variable. Third, choose a method for generating random numbers or pseudo-random as the probability distribution to represent good series and the numbers are within the range of actual values of the variable. Fourth, are established a set of random numbers which are in the direct correlation with the cumulative probability distribution of each variable. For every random variable is associated with a simulated value of the variable studied. Fifth, value chosen for interpolation searching corresponding values for the variable of interest. Seventh, calculate the value variable functional performance, studying the values obtained by calculating the arithmetic mean and mode or mode median or amplitude, standard deviation or maybe dispersion or coefficient of variation, etc. If the standard deviation is high, we have to increase the number of observations on the phenomenon. And based on the result, a decision of the optimal model, it will be taken. I will share my screen now because after this short introduction, I would like to solve a real problem as to explain how this uh, simulation, Monte Carlo simulation, works. Let's see, we have this problem. We want to launch a product on a new market. Following a market survey, our company wishes to launch a new product in a market considerable stable, and the company gets the information so in the metrics on the right side. For example, V came from volume and vary between 150 and 450 15 pieces of product million. Okay, so beside we can see the probability for each quantity. For example, for 100 mil pieces, we have a probability of 0.1. For 248, we have a probability of 0.18. For 320, we have a probability of 0.2. And for 415, we have a probability of 0.52. These values came from the market survey, I must say one more time, and from the experts' experience. Also, the unit price may vary between 38 and 44. We have here the price for the price 38, a probability of 0.1. For a price of 40, we have the probability of 0.5. For the price of 42, we have a probability of 0.35. For the price of 44, we have a probability of 0.15. Let's see now the cost for variable cost for unit. It was forecasted to be between 18 and 23. So for the variable cost being 18, we have a probability of 0.15. For 20, for variable cost of 20 ROM, we'll have a probability of 0.3. For the variable cost 23, we have a probability of 0.5. For another 23, this is a small mistake, we have to correct it. I have a probability of 0.15. This was 22. For fixed cost, the market survey and the experts in the field found that this fixed cost may vary between 378 with a probability of 0.2 to 4,918 with a probability of 0.1. As to estimate the profit, we may use all these four metrics, meaning that profit will be volume of sales, multiplied by price minus variable cost minus fixed cost. Okay, now we decided to use Excel because this is a software that all the teachers and the students have access. Hereby, we have all the metrics above with the probabilities that we have discussed. For example, for sales volume, we have this sales volume, yeah, and also the probabilities. For the unit price, the data problems, yeah, data presented before, and also the probabilities. For unit cost, 22 here, as we see, 23 here, okay. And for the fixed cost, also 3,788 rows with a probability of 0.2, 4,658 with a probability of 0.25, 4,788 with a probability of 0.25. And here we have the profit formula, because we are supposed to find out which will be the median profit, which will be the probability to record losses from this product sale, which will be the probability of recording profits greater than 1,000 monetary units, which will be the probability of losing more than 2,000 monetary units. So this is the first step that we have to do for getting the results of this problem. And then all these templates and let's say machine learning patterns will be uploaded in a cloud version of our let's say network, We will intend in the future to create a virtual network in which all the students and teachers can meet each other and simulate together different kind of problems. This is a very small problem, but we just want to start from an easier to be understand. A problem in economic field that we address in our problem in our project, especially to economic field, professor in economic field. So we decided to take an economic example. Okay, what we do next? We have to calculate uh, the cumulative probability. I think I have to go on the Excel that is in Drive because I can enter formulas here. Just a moment. The other one, don't let me edit. Okay, so let's see. Here we have to calculate the cumulative probability, which means that in this cell I have to copy the element above. In the other cell, I have to uh, to make a sum between the first probability and the second probability because we are talking about cumulative probability. In the third cell, I have to add the second probability with the third probability. And of course, in the last cell, I have to add the last probabilities that we have. So this way we can find which are the random number intervals. For example, we will know that if we sell 100 problems, the probability will be between 0 and 0.1. If we sell 248 products, million problems, the probability will be between 0.1 and 0.28. If we sell, for example, 320 products, million products, the probability will be between 0.28 and 0.48. And of course, in the end, if we sell 415 million products, the probability will be between 0.8 and 1. We have to do the same thing for the price, meaning that the first two rows are problem data, that we have this data from our survey and our specialists, and now we have to add formulas again. So, as we did for the volume sale, now we do for the unit price per product. We copy the probability above, we sum again the probability that we already have it in here. Something went wrong. I have to put the formula in here. Okay, so here we have 0.1 plus 0.4805. Here we have 0.5 plus 0.35 and we have 0.85. Here the same, 0.85 plus 0.15, we have 1. So 0.1, 0.5, 0.85, and 1, let us know which will be the random number interval. Okay, so here we can stop in 0.1, here we can stop in 0.5, here we stop in 0.84. Let's 85. Let's see what's the next step. The next step is to calculate cumulative probability for unit price. And I will not show you the steps again because they are the same as you can see here. Orange and purple, yeah. We added orange and purple. Here we added orange and purple, yeah. And also for the unit cost uh, for per product, we have variable cost here. We have also the problem data. These are the problem data. And also cumulative probability and random number intervals. Mai departe, for fixed cost, we have the same. We have the same element. And now, let's to make on let's say an average maybe, but it's not really an average. It's a main idea that will take into account all 5 possibilities with their associated probability. We have to add a sum product formula, which will ask us which is the first array. This is the first array, isn't it? Just a moment. And which is the second array? First array C8, F8. Second array C9, F9. And this formula will do this thing. 150 multiplied by 0.1 plus 248 multiplied by 0.18, 320 multiplied by 0.2, 450 multiplied by 0.52. And they will add all these multiplications. Okay? So that we can have the 339.44 numbers that of products that could be sold. The same will do for the price. We will make, let's say, an average price using some product formula. We'll do the same here. Some product formula for understanding which will be the variable cost. And in the end, we will do the fixed cost through some product formula to evaluate which will be a median or an average fixed cost. Then, of course, we use our formula, as we said before, meaning that we have to multiply the volume, the G8 volume, by unit price G45, this value, minus the variable cost, this value, closing the brackets and minus the fixed cost. So we'll get a median profit of, let's see the value, just a moment, and it's not listening to me, a median profit of 2,297 around million around. So this will be the first the answer of the first question. By now, we haven't used at all Monte Carlo simulation. Um, from this moment on, we will start to calculate the probability to record losses from the product sale. So we estimated that we might have this profit, but now we have to know which will be the probability to record losses from this product. For that, we have to use Monte Carlo simulation. And what we are doing is to use a random function as we presented above. Meaning that in this cell, I have to use random between I was expected to see the formula. Yes, and random. Okay, it seems that appear random between, and they ask me which is the lowest value. Let's say 0 to 100 and enter. Usually, when we use Monte Carlo simulation, we have to associate at least 5,000 random values for each factors that create our form, meaning that I have to associate 5,000 random values for sales value, volume, 5,000 random variables for unit price, 5,000 random values for unit cost, variable cost, and 5,000 variables, random variables values for fixed cost. Of course, in Excel, it's not easy to work with 5,000. I mean, it's the same, but it's not to go in an entire file. We used for this example only 50 values, not 5,000. Only 50 generated random values. So we decided to put this formula here, random between 0 to 100, and with autofill function, we have to copy this formula by the end of the 50 recall. We will see that new values appears in our tables. Now, having in mind that this value is 68, we can see that the interval is around here. 68 is between 0.28 and 0.48. No. It's in here. It's higher than 0.48. Thus, in this cell, it has to appear 450 values. For 3 is in this value 0.1. Again, 3. It being a random function, so we can take the values as it is generated. Six 0.48. 82, the same, is associated with the value 450. 22 is in the interval 0.1, 0.28. So here we will have 248 values. And so on. We have to do these steps for 5,000 random variables associated with our sales volume. Why? Because we have to estimate some risk factors that we cannot predict it, and this is the reason that we associate a random function. we associate a random function to simulate some risk factor that might appear in our simulation, in our process of launching a new product on a stable market. Even being a stable market, there are a lot of elements that can influence our economic problem. So this is the reason that we have to use this associated random values that are taught by Monte Carlo simulation. Okay, we'll do the same for 55 for price, meaning that here we will use a random function, random between 0 to 100. And of course, we will copy with autofill function by the end of this simulation. Okay. Oh, we can see that all the values are updated with each click on this worksheet, meaning that the simulation is done over and over and over again. Let's see, for the price we get 97 value. 97 value is 0.97 is in this interval, so we will have the price 45. 86, the same is in this interval, so we'll have the price 45. 68 is in the interval of 0.5, 0.85, meaning that the price will be 42. And so on. We do this for all the price values. The same we'll do with the unit cost. We generate a random function and then we will go here and see which are the associated values. For example, for 1, we can find the price of 80. For 86, we'll see the price of 23. For 47, we'll see the price of 22, and so on. We'll do the same for fixed cost. As we may see here in this table. Okay, fixed cost for 19, we will have, let me see, what will be the price, 19. 19 is here. The price will be 3,788. For 27, for example, we'll have this price 4,658. And so on. For, let's say, 63, 63 is in this interval, so we'll have the same price. For, let's say, 79, 79 is in this interval, so the price will be 4,918. Okay, so hoping that you understood that for each of our 4 factors that influence the profit, meaning sales volume, unit price per product, cost, variable cost per product, and fixed cost, we associating, in this case, only 50 generated random values, but usually we have to generate 5,000 values. So, what's next? First of all, I have to explain how we wrote this long formula over here. It will take some time. Usually for us, it's very easy to understand because I just explained that I went here and saw that 17 is in this interval, so I associated with 248. But in Excel, we have to to make this complex formula that means that use if function, and we will say like this: if this k10, meaning 17, then is less than 0.1. Here 0.1 is dollar C10, meaning that we are going to relate to this cell 0.1, meaning C10 cell. The reference of this cell is C10. We use dollar to freeze this cell as to copy this formula along. So if 17 is less than this interval, then 0.1, then multiplied by 100, then we will choose C8 value. C8 value is 150, C8 value, okay? And then, if not, we will put again another if function, and this time we have to add an AND function to check if 17 is greater than 0.1 and less than 0.28. So is greater than C10, as you may see here, and less than D10, this one, 0.28. And if it is like this, then we will put the value, we will write the value 248. Otherwise, we will add another if formula with an AND formula too, meaning that now we have to compare to check if 17 is in the interval is greater than 0.28 and less than 0.48. So in this case, we will add the value, we will write the value 320, and if not, we have only to check, we have only one if this time, to check if it's greater than 48. So we may see that at the end of at the beginning and at the end of the formula, we check only if it's less than 0.1, if it's less than 0.48, and for these two cells, we have to add also an AND function. So this is the formula that we use in our XLS file for all the values, for sales, for price, for unit cost, for fixed cost. Okay, what's next? Why did we do that? And because the question of our problem is, just a moment to say it in here, the question is to find out which is the probability to record losses from this product sale. Okay, in this case, we will have to do another step in our analysis. We use 2000, 1000, 0, minus, we would say minus 2000, minus 1000, 0, 1000, 2000, and so on, yeah, for dividing our profit. Meaning that now we have to check if this value is less than 2000 or is between between minus 1,999 and minus 1,000, then to check if it's in this interval, then in this interval, or this. In our case, is greater than 2,000, so it is in this interval, greater than 2,000. Okay, as we may see, the formula is easy. Here we check if this value 2,650 is less than 2,000. If it is, we will write 1. If not, we will write 0. The same in here. We will check if it is. We have here an AND function because we have two elements from our interval, minus 2,000 and minus 1,000. Okay, and the same here, an AND function between 0 and 1, an AND function between 1,000 and 2,000, and so on. So these intervals, 1,000, 2,000, are chosen by us because the problem asks us which is the probability to get more profit than 2,000 or less profit than 1,000. So this is the reason that we choose 2,000, 1,000, and not other value. We can use any value that we want to do. So with this formula, we also use autofill and copy down. Okay. Undo. We copied too much. Just a moment. So the formula, we can just do double click on here and the formula will be copied for all the intervals. Okay, this is autofill function. Okay, good. So now we have to do the final check and to answer to our last questions. Hereby, we will count how many elements we have in this interval that are 1, meaning how many elements are less than minus 2,000 divided by 50 because we have 50 elements in here. If we had 5,000, we should divide this with 5,000. Here we have the same formula counting 1, how many times 1 appear in this column, divided by 50. How many times 1 appear in this column divided by 50? How many times 1 appear in this column divided by 50, and so on. How many times 1 appear in this column divided by 50. So that here is an average for all the generated values. So this is the median profit calculated by MonteCarlo simulation. The other one was the median profit calculated only by using our formula without using random functions. So this is the difference. This is the median profit of 2,297. This is the fixed value. The other one is a generated value, a median profit 2,511, generated with a specific standard deviation and a confidence level interval, meaning that here we have also a probability. In the first case, it was only a formula that will not take care of any risk associated with our formulas, with our managerial process, innovative process. So this standard deviation is calculated, of course, with suited function, standard deviation function. The interval, confidence interval, is calculated by with the confidence function. Okay, now we have to answer to the last three questions of the problem. The probability of recording losses is 0 for why? Because as you see here, we have to sum the three intervals. Why? Three intervals. Let's see, probabilities to have losses to be under 0 is in here. This interval, this interval, this interval. So now we will add all the probabilities, cumulative probability of three intervals. 0.01, 0.02 plus 0 plus 0.12 will be the probability of recording losses, 0.14. Okay, the probability of recording greater than 1,000 units monetary units. 1,000. Let's find 1,000. Is in here to be greater than. So we have to add the last two intervals. Okay, we will add, as you see here, the last two intervals, 0.12, 0.64. Okay, and the probability of losing more than 2,000 monetary units. Why? This is the probability of losing more than 2,000 because this interval, as you may see here, is minus 2,000. So this is the way we can explain step by step how to use Monte Carlo simulation in an innovation management process in economic field. So what we do next is to integrate this kind of algorithm in a specific application, and all the students and teachers could simulate more and more cases, adding more and more level of variables and questions, different questions to answer using the Monte Carlo simulation and calculating the risk associated with the probability of implementing our project. In here, we also calculated a minimum profit if we want to using a SQLT function, meaning squared radical square function, and also a maximum profit if we want to. But this is, the answer of our problem is 0.15, 14, 0.76, 0.002. So in our cases, with the prices and the cost associated to our product, we have a great probability to have profit greater than 1,000 million units, monetary units. So this is the answer to our problem. We will come soon with other examples, like, for example, Monte Carlo simulation, like cojoint analysis, like time series, like decision-making tree, and so on and so forth. But by now, I just wanted to show you that we can teach computer how to make decisions. This is Machine learning is the first step to artificial intelligence. So this was the reason that we use Excel, Microsoft Excel, because it's free to use for all of us, students and teachers. So we can do it. We can do the first step of machine learning. Then, in another step, we have to integrate all our application in a cloud network dedicated to teacher and students for interacting and simulating and playing with the computer against the computer in taking decisions. Thank you for your um, kindness and attention. And we will soon invite you to a specific training as to be easier for you to understand all these simulation models. Have a nice day.